Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Physics Revision Lesson series. Today we will run through the atomic structure and EM radiation. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. Firstly, just as cells are building blocks of life, atoms are building blocks of all matter, where they make up all substances. Atoms are very small as they have a radius of about 1 times 10 to the power of minus 10 meters. An atom consists of a small nucleus which is surrounded by electrons. If you need to revise this topic, we have made a video on the atomic model to help out. The radius of the nucleus is less than 1/10,000th of the radius of the atom. Therefore, an atom is mostly empty and most of its mass is concentrated in its nucleus. Inside the nucleus, there are protons, which are positively charged and have a relative atomic mass of 1, and neutrons with no overall charge that also have a relative atomic mass of 1. If you look at the diagram, you can see that protons and neutrons make up the nucleus at the very center, with electrons that are in shells orbiting the nucleus. We have discussed when and how electrons were discovered in the past, but now let's learn more about the structure of an electron. Electrons orbit the nucleus at specific distances and fixed shells known as energy levels. Electrons are negatively charged with a relative atomic mass of 0.0005, which is very small and is often referred to as negligible in exam questions. The higher the energy level, the greater the distance from the nucleus. Energy levels further from the nucleus are at a higher energy than energy levels closer to the nucleus. This is because the distance between the negative electrons and the positive protons in the nucleus is greater, so there is less of an attraction force. Therefore, greater energy is required to keep the further away electrons within the atom. If we look at the diagram, you can see that the nucleus is at the very center, with lots of energy levels surrounding it, and electrons orbiting the nucleus within fixed distances from the nucleus itself. At GCSE level, you only need to know a few things about energy levels, one being each energy level's capacity. Each energy level can only hold a specific number of electrons. As you can see in the diagram, the first energy level can only hold 2 electrons. The second and third energy level can both only hold 8 electrons. This key sheet or table is important for you to learn. It summarizes all the properties of subatomic particles that you need to know for your exams. So for example, the 3 subatomic particles you need to be aware of are protons, neutrons, and electrons. For protons, the relative charge is +1 since it's positive, and the relative mass is 1. For neutrons, there is no charge, so it's 0, and the relative mass is 1. For electrons, the charge is -1 since it's negatively charged, and the relative mass is 0 or 0.0005, as electrons are very small, so its mass is negligible. Moving on to the absorption of EM, which is an abbreviation for electromagnetic radiation. Electrons can change energy levels if they gain, which is absorption, or lose, which is emission energy. If an atom absorbs electromagnetic radiation, an electron can move up from a lower energy level to a higher energy level. This moves the electron further away from the nucleus, as shown in the diagram. You can see that EM wave is being absorbed from the environment, which causes the electron to move up an energy level. Now let's look at the emission of EM. Eventually, the electron will become unstable, therefore it will lose and emit EM radiation. If the atom emits electromagnetic radiation, the electron can move down from the higher energy level to the lower energy level, therefore it will move closer to the nucleus. So as you can see in the diagram, an electron has become unstable and therefore an EM wave is being emitted, and therefore that causes the electron to move down an energy level. Now let's put our knowledge about the atomic structure and EM radiation to the test and see how much we have retained from this topic. The first question is a multiple choice question. Answer this independently by pausing the video and then return so you can mark your answer and add any corrections if needed. The nucleus contains subatomic particles. These are protons and electrons, electrons and neutrons, neutrons and protons, or ions and protons. The correct answer is protons and neutrons, which make up the nucleus of all atoms. The next question is a calculation question. An atom has 6 electrons, 6 protons, and 7 neutrons. Calculate its relative mass. Show your working out. This is a 2-marker, which means that you need to show at least one step of working out and one answer to get both marks. Once again, try this independently and then we will go through this together. The answer is 13. This is because the relative mass of only the protons and neutrons should be considered, as electrons have negligible mass as they are so tiny. So add together 6 and 7 to give you 13. The next question is to explain what happens when EM radiation is emitted by an atom. This is just 3 marks, so think about the scientific content we learnt. Explain questions generally are just content and recall questions and need you to tell the step-by-step process like a recipe, so as long as you learn the content well, explaining questions should be a breeze. The answer is that the electrons move down from the higher energy level to the lower energy level, and the second mark is to explain that it therefore moves closer to the nucleus. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2 and 3, along with specially formulated 11+, GCSE and A-level lessons. Further information can be accessed on our website at tessonlineschool.com. And if you would like further resources, advice and feedback, please contact us on the following numbers. Thank you.